Hi, my name is Milan. I'm a software architect and Microsoft MVP, and in this video I'll show you how to build a real-time stock price monitoring dashboard using .NET and SignalR. Here's a preview of what we're going to build in this video. It's a dashboard that allows you to specify stock tickers that you want to track and is going to update the price in real time. The price updates are going to be streamed from the backend into the user interface using WebSockets and SignalR, and from the user interface you can observe how the price changes every 1 second. Now, the original price of the stock is the actual value that's pulled from the stock market at this point in time, and then the updates are going to be randomly generated on the backend and pushed to the client using SignalR. To introduce an additional ticker, you're going to specify the ticker value and then press add stock. That's going to reach out to the backend to fetch the initial price, and then the backend is going to start streaming the price updates. There is even a simple drag and drop functionality which doesn't function all too great, but essentially it does work. When you're done tracking a ticker, you can click the X button to remove it from the user interface, but of course you can add it back later if you want to continue tracking it. So this is going to be our UI. Now let's jump into the backend and let's see how we can implement support for something like this. Writing the code for this entire video from scratch would be too much for this one video, so I already prepared some things behind the scenes, and the only thing that's missing is for us to implement the real-time component. So let me walk you through what I currently have. We're using a Postgres database to store the stock prices, and I'm using Dapper to communicate with the database. I have a background job that's going to initialize the database when the application starts if it doesn't exist, and it's also going to create the necessary tables. Then I have a stocks client. This is a typed HTTP client that's going to communicate with a third-party API to give me back the initial stock price if I don't already have it in the database. And then the stock service is what I will use to fetch the latest stock price, either from the database if it's there or from the third-party API if it doesn't exist. I'm also configuring CORS for the user interface, and then we have one API endpoint that allows us to fetch the latest price for a given ticker. So let me show you how this works. Let's say I specify the Microsoft ticker from the Swagger UI and I send this request. It's going to land on the breakpoint in the one API endpoint that I have defined on this API. So this is going to use the stock service, and then this is going to call the getLatestPrice from database method. And essentially this is just a SQL query using Dapper that's going to select the required data from the stock prices table that is created by our background job if it doesn't exist. If we get the result back, then we're going to return that. But let's say I simulate that I don't have the result back, so I want to return null. And this is going to cause me to reach out to the stocks client, which is going to call a third-party API to fetch the latest stock price. So this might take a moment. We get the response back. We're going to log that information, and then let's return the stock price response. And this contains the latest price. Now I'm going to save this into the database for future requests, and then we can return this price from our endpoint. So I'm going to hit continue, and in the Swagger UI, we get the ticker that we were looking for and the latest price, which is 417.4. So this is going to be our initial endpoint that the user interface is going to call to fetch the latest price, and then it's going to connect with our SignalR hub that doesn't exist just yet, which is going to stream the price updates for a given ticker. Let me also show you the database initializer. It's first going to ensure that the database that we want to use exists, and then it's going to initialize the required structure, which is just one table. Here is the SQL that's going to create the database if it does not exist. And then the next step is to create the database structure, which is one table called stock prices, and it's also going to create some indexes that are going to speed up our queries. So that is the database structure. We're not going to be paying too much attention to that. And now let's focus on the real-time component that is going to use SignalR. So let's go ahead and include the required services into our dependency injection container, and we have to call builder services add SignalR. If you are running .NET 8, this is already available, so you don't have to install any additional NuGet packages. The next thing we need is our actual SignalR hub, which is the central component that is used to connect to our server using WebSockets or some other fallback mechanism. And let's create a new class in the real-time folder that I'm going to call the stocks feed hub. I'm going to make this an internal and sealed class, and the base class for implementing a SignalR hub is the hub class. You can choose between a basic hub class or a generic one that allows you to implement a so-called strongly typed hub, where you have a client interface representing the methods that you can invoke on the client side. So let's say I define an interface called iStockUpdateClient. I can then use this interface to make my SignalR hub strongly typed. Now let me show you what a difference this makes. I'm going to override the onConnected async method, and this allows me to access the connected clients. So let's say I want to broadcast something to all of my clients, and this isn't a strongly typed hub. Then I have to use the sendAsync method, where I need to specify the client method that I want to call using a string. This isn't strongly typed, it's prone to errors. I also have to specify the arguments one by one. A strongly typed client makes this a bit simpler. So let's say I have a record called stock price update, and I want to send this record to my client. I can create an async method on the stock update client interface, and let's call this the receive stock price update method. Then I can specify the stock price update record, which is the argument for this method, and we can give it any name we like, let's say update. And then if I make my SignalR hub strongly typed by just specifying this interface, you will see that the sendAsync method disappears, and all I have access to on the client methods are the methods that I have exposed on the interface that I'm using for the strongly typed hub. So all I'm allowed to do is call the receive stock price update method. And this is an excellent way to streamline how you work with SignalR hubs. So for now, I don't need anything inside of my hub. And then let's go ahead and move these additional types into their own files so that I only have one type per file. So now that we have our hub, we also have to expose it from our backend, and we can do that by mapping the hub by calling the map hub method. You have to specify your hub type. I'm going to say stocks feed hub, and then you can define a route where you want to expose this hub. So I'm going to say this is the stocks feed route, and here is where you can connect to my SignalR hub. So the next component that we are going to need is a background job that's going to generate the price updates and stream them to our clients using the SignalR hub that we have in the backend. So I'm going to create the stocks feed updater class. I'll make it internal and sealed, and it's going to implement the background service class. This class has one abstract method that we have to implement, and it's called the execute async method. And inside of it, I'm just going to run a continuous loop that is going to update the stock prices for currently active tickers, which is something that we'll have to keep track of, and is going to generate a new price and send that to the clients using SignalR. So I'm going to start off by introducing a class that I'm going to call the stock update options. And this is going to contain an interval, which is a time span, representing how often I want to update the individual prices. Let's say that the default value is 5 seconds. And then I have another configuration parameter, which is going to allow me to control how much the price can vary every time I run the stock feed updater. So let's go ahead and move that into its own file, and I'm going to configure this options type from my program file by pulling from the stock update options section, which I already added ahead of time, and I set the update interval to 1 second and the maximum percentage change to be 0.002%. So this takes care of the values that I want to be configurable. Now let's focus on the stocks feed updater. I'm going to inject a couple of services that I will need to implement this, and I'll need the service scope factory to resolve the stock service that I will use to fetch the latest price. Then I'm going to need an iHub context, which is how you can interact with SignalR from your backend. And this is important because I'm running this in a background job, which is outside of the context of an HTTP request. So what I can do here is inject an iHub context, specify the hub type and the type client, which is the iStockUpdate client. And the hub context will allow me to invoke methods on the hub that I can asynchronously send to any clients. Let's also inject the iOptions of the stock update options, and let's also inject an iLogger for logging the important things that occur inside of this background job. Then I'm going to create a random instance, and I'm also going to store the stock update options into their own variable. And I'm going to pull that from the value that I get in the constructor. And then the execute async method becomes more or less simple. I want to have a while loop that's going to run until the cancellation is requested. So I can say while not cancellation requested, then do some work. And the work is going to be calling the update stock prices method. That doesn't exist yet, but we're going to implement it. And then you're just going to say await task delay, and we have to specify a time span. And we have this value on the update interval option, and I can also specify the cancellation token. So now I have to implement the update stock prices method, and this is going to be a private async task method. I will call it update stock prices, and this is where we are going to implement the important logic for updating the prices. So I first want to create a service scope, and we're going to use the service scope factory to create the scope instance. Then I'm going to use the scope to resolve the stock service, which is a scope service. So I can say scope service provider, and I want to call get required service, and then let's resolve the stock service. And then essentially what we want to do is have a for each loop that's going to somehow loop through the active tickers, which are the ones that are currently present in the dashboard on the user interface. And for each ticker, we're going to use the stock service to fetch the latest price, make a small adjustment to the price, and then send that to the client. Unfortunately, we don't have a simple way of how we can track this, so we have to implement this ourselves. So I'm going to add another type here that I'm going to call the active ticker manager, and this is just going to be another service and is going to be a singleton. Because this service can be used concurrently, I'm going to use a concurrent collection. And the one that I'm looking for is the concurrent back. And I'm just going to store the string values inside, representing my active tickers. So let's call this the active tickers, and I'm going to initialize it to an empty collection. And then I'm just going to expose a method called add ticker. Is going to accept a ticker as the argument, and if the active tickers do not contain the ticker that I have specified here, then we're going to add that value. So I will say active tickers add and specify the ticker inside. And then let's also expose a method that's going to allow us to fetch a read-only collection of strings, and we're going to call it get all tickers. And what we're going to do inside is just say return active tickers to array or to list. Any one of these works fine. Then I want to register this as a singleton. So I will say builder services add singleton and specify the active ticker manager. And then it's important to use this service when somebody requests a value for a given ticker. So we're going to have to use it in our stock service. So let's inject the active ticker manager. And essentially what I want to do when somebody fetches a database price, I want to say active ticker manager add ticker and then specify the value. I also have to make sure to specify this after I fetch the price from the API. So I'll have to add another call here, and this will take care of filling the concurrent bag, which is going to allow us to iterate over these values in our background job. So let's inject the active ticker manager here, and then I can use it from my background job to fetch all of the tickers, and then I can iterate over them one by one and implement the price update and send that to the clients using SignalR. So we're first going to fetch the current price for a given ticker from the stock service. If by any chance this returns null, then let's just continue. And then we have to calculate a new price using the current price for a given stock. And I'm going to add this method that is going to take the maximum percentage change from our stock update options, use that to produce a price factor, and then based on the price factor, we're going to calculate a new price that we're going to add to the current price. Now the price change could be positive or negative, and we can use this on the user interface to represent if the price is increasing or decreasing. So now I can say that the new price is equal to calculate new price, and I'm going to pass the current price value, and then we have to create a new instance of the stock price update. We can specify our ticker and the new price, and we just want to send this to our clients. So what we can do is say await hub context, and now I can access either my clients or the groups. Now let's say I choose to send this to all of my clients. I can say clients all receive stock price update and then send this value. And then let's add an information log that we have updated the ticker price to the new price value. The potential problem that we have here is that this isn't really an efficient way to stream updates using SignalR, because we are sending this update to all of our clients. This also means that we are sending a price update for a given ticker to clients that may not even have this ticker or stock on their dashboard. I'm bringing this up because I see people use SignalR all the time like this, just streaming all of your updates to all of your clients, which is a terrible waste of resources and bandwidth. So a better version would be to say await hub context, take your client, but this time we only want to send an update to a particular group. And we can use the ticker value as our group name and then say receive stock price update. This approach is far more efficient because we are only sending the stock price update to the clients that are actually interested in this specific ticker. We also need to let our clients let us know that they are interested in a given ticker. So we have to allow them to somehow subscribe to a particular group. And we can do this from our stocks feed hub by just exposing a method. This could be a public async task method. Let's call it join stock group. And all you have to do is specify a ticker value. And then I can say await, select the groups, which is an instance of the iGroups manager. And this lets me add the current connection to a particular group or remove them from it. So I can use the context connection ID to specify the connection ID value and then the ticker as the group name. And our clients are going to call this method after connecting to the hub. For each of the tickers that they want to receive updates for, we are going to add them to a particular group. And then from the background job, we're going to send the updates only to this group for a given ticker. All that's left is to add this as a hosted service. So I need to say builder services add hosted service, specify stock feed updater. And now we are ready to start the application. So I'm going to place a breakpoint in my stock feed updater, and let's specify the breakpoint here where we have some active tickers. Now you will see that I'm going to hit the breakpoint here, and if I hit continue, we won't land on the breakpoint inside of the for each loop because we aren't listening to any tickers. However, if I go back to the user interface and select the price for the Microsoft stock, we will immediately land on this breakpoint because now the Microsoft ticker is part of the active tickers in the active ticker manager. So this is going to calculate the current price, give us back the updated price, which is just slightly different than the current price. You can see that it's a bit less. And then we're going to send the update using our hub context. Now, right now, we don't have any SignalR clients connected to our hub, so unfortunately there will be no clients to receive this update. Now, let's go over to the client application, and I want to walk you through what is going on there. The user interface that you saw at the start of the video is just an HTML file and a single JavaScript file. The HTML is going to use the SignalR JS library to connect to our dashboard, and there is not much going on. Most of the logic is inside of the JavaScript file. So let me walk you through what is happening here. We have the root URL for the API, which is HTTP localhost 5001, and we have a bunch of code that's responsible for connecting to SignalR and also rendering the results on the user interface. If you want to check out all of this source code, you can grab it from my Patreon. I'm going to walk you through the most interesting parts. The stock widget class here is responsible for a given ticker, and it's also going to get the SignalR connection so that it can join the specific group. Now let's go down this JavaScript file to this part here. Let me find it. So here we are using the SignalR JavaScript library to create a new hub connection builder, specifying the URL where the stock feed hub is exposed, which is this URL. And then we're going to build the connection. There's a function here that's going to start the SignalR connection by saying connection start, and is going to load some predefined tickers. I define these in a helper function, and it's just going to load some tickers whenever you open up the dashboard. For each of these tickers is going to call the add stock method, and what this method is going to do is create a new stock widget instance, append that to the container on the user interface, and if I go into this constructor, you will see this fetch price method, and essentially this is going to call our API, and this is going to send the initial GET request to load the price. It's going to update the user interface with this price, and then it's going to join the SignalR group for a given ticker by calling the join stock group method. And then SignalR is going to start streaming these updates for this particular ticker. Now there is also this part of code here that is reacting to the price updates from SignalR. So there is the receive stock price update method, and when we receive this message, we're going to get the stock update object check if we have a given stock widget for a given ticker, and if we do, we're going to update the price based on the price that we get from SignalR. So finally, if I run this application using a local HTTP server and I open up localhost 3000, this is what you're going to see. So the initial stock tickers are loaded into the user interface, and our stock feed updater background service is going to stream price changes to the user interface. We're going to dynamically react to these changes and render that as part of the UI here and also in the stock price. Now, if I refresh this, we're going to first load the initial price and then start updating the chart as we receive updates every 1 second. If I open up Docker Desktop, you can see the logs from our stock feed updater, which is updating the price of the currently active tickers every 1 second in the background. And then it's sending these updates in real time to our client. So you can see how we can use SignalR to build an interactive application that's going to react to the changes from our backend. To make this even more interesting, we could hook into real-time data on the stock market and start streaming that into the user interface instead of having to randomly generate this on the backend. But the overall idea is going to remain the same. Your backend is going to have to connect to the real-time feed, and then it's going to have to stream that to the clients using SignalR. If I go ahead and open a few more tabs with the same address, all of them are going to connect to SignalR. Now, what's interesting is that I can add different stocks into the different tabs. So let's say I want to look for CrowdStrike here, and then here we can add Apple, and then here I can remove something like NVIDIA, and each of these tabs is going to have its own state and its own connection to my backend, even though they are running on the same URL, because each browser tab is treated as a separate SignalR connection. If you are looking for an introduction to SignalR, then I recommend that you check out this video next, and if you enjoyed this video, then make sure to click the like button. Check out my clean architecture and modular monolith courses to improve your skills, and until next time, stay awesome.